In example 1, we're going to simplify the complex fraction by multiplying by the common denominator of the smaller fractions. So we can see that the common denominator is going to be 4x, because we have a 4 in this denominator and an x in the other two. And this will effectively eliminate the double fractions, the fractions over and inside of another fraction. So we'll multiply every term by 4x. This is effectively multiplying by 1. You think about multiplying by 4x over 4x. We multiply any expression by 1. That's the reason we can do this. So once we have this set up, we will just cancel each term and do our multiplication. So we'll cancel the x's, and we will get 8 plus x times x, which is x squared, all over, cancel the x here, 4 times x plus 1, which is 4x plus 4. Remember that the 4 has to be multiplied by the entire quantity x plus 1. And then we can rewrite our term in standard form, x squared plus 8, all over 4x plus 4. You always have to check and make sure that this rational expression does not simplify. You completely factor it, but x squared plus 8 does not factor, and because of that we don't have to go any further because there's nothing that can factor and cancel in this expression. So this is our final simplified expression. In example 2, we'll employ the same method. We will multiply both the numerator and denominator by the common denominator x. This will eliminate these two fractions, but we have to multiply all terms by x, multiply through by x. You could just have put parentheses around this and distributed the x by writing the term, or what we're multiplying by, next to every term. That way it cancels and we can see it very cleanly, what's left. And so we end up with 8x plus 4, and we end up with 6x plus 3. And then we're going to factor out our greatest common factor of the numerator and denominator, or we're going to completely factor these. And we'll get 4 times 2x plus 1. It's 2x plus 1. And we're going to factor out a 3 and get times 2x plus 1. And we can cancel or divide the 2x plus 1's to be 1. And we end up with the final solution as 4/3. Let's take a look at example 3. I will be working example 3 by two different methods. One method is the method that I think is easiest, which is multiplying by the common denominator in the numerator denominator. And the second method is combining the denominator terms over a single common denominator. So I'll work both methods here, and you can choose whichever one that you think is easier on any problem. So let's begin by working the method we've already explored by multiplying by PQ over PQ. And again, we're going to multiply all the terms by PQ. So PQ times 1, PQ, put a PQ here. And we're just going to cancel, and we end up with PQ over Q plus P. So Q times 1 is Q, and the P times 1 is P. Now, you can see that simplifies very quickly, very easily, makes a lot of sense. I tend to find that this method solves the problem quicker and easier than this other method. So we'll call that method 1. And then we'll over here and we will solve using another method, method 2. So let's rewrite our complex fraction. 1 over 1 plus P plus 1 over Q. In this method, we will get a common denominator only in the denominator. So I will multiply this term by Q over Q and this term by P over P. This simplifies down to 1 over Q over PQ plus P over PQ. Now we will multiply by the reciprocal of this fraction. So this ends up being p plus q over pq, and then we'll take 1 times pq over p plus q, and you can see that we end up with the exact same expression. It just took us a few more steps to get there. I would say there are some instances where method 2 is a simpler way to solve, especially if you don't have to get a common denominator. You can just multiply by the reciprocal of the denominator. That sometimes will result in a shorter process to simplify the expression. But knowing both methods and using them and employing them to simplify a rational expression is always a valuable tool to have in your toolbox. If you found this video helpful, be sure to hit the like button below. Subscribe to the channel so you can be notified whenever we release a new video. And if you have a comment about simplifying complex fractions, leave that down below. I'll be happy to help anybody out. See you guys next time.